Give me a yes, no. All right. So yeah, actually, it's a good thing you mentioned that, Mitch. I wasn't going to say anything about this, but since you brought it up, there's well, to cut to the chase here, I used to work in underground detection, and I don't anymore. And I used to think, well, you know, if I really want to make a difference, maybe I can be the anti-dowsing guy, because I can tell you why it doesn't work and the things that do work. But, you know, it was tied to my professional reputation at the time. And believe it or not, in industry, there are a lot of people who believe in dowsing. In fact, you can count the ones who don't believe in dowsing just a little bit on one hand. It's kind of sad and strange, and we can talk more about that later on if you like. So yeah, like Mitch said, let's talk about something fun. Let's talk about something stupid. The real secret of the Skinwalker Ranch. This was a show on History Channel this past spring, the spring of this year. Basically existed to capitalize on the success of Curse of Oak Island, which was actually very popular. And then they kind of threw the same tactics at this, and it wasn't very interesting. And this is the star of the show, literally and figuratively. This is ground penetrating radar, GPR for short, big buzzword in the industry of underground detection. I will talk more about this in detail coming up. So here is, by the way, no confirmation bias here, right? They only put aliens on the friggin' gates. This is the entryway to the Skinwalker Ranch, which is a 512-acre ranch in Utah that has been reported to have strange occurrences for decades, hundreds of years. It depends on who you believe and how much faith you want to put in. All kinds of different things, like, well, it's called Skinwalker Ranch because it was an Indian reservation or something related to the indigenous peoples at some point. You've probably heard of the legend of the Skinwalker, a shapeshifter in certain indigenous cultures. So yeah, people have seen skinwalkers, people have seen dogs, people have seen UFOs, people have seen Bigfoot coming out of a dimensional doorway. He's two-dimensional, he steps out of the doorway, and all of a sudden he's three-dimensional. And you have your transhuman Bigfoot, which is one of those things that fascinates me. We haven't had this yet, no Bigfoot with monolith. But you have to assume it's coming. By the way, as a geoscientist, my degree is in geophysics. Can I just say, these metal things are not monoliths. Lith literally means rock. Okay? I mean, what did I say earlier? You know, maybe I'm just a stickler. I am on the spectrum. Maybe, you know, but no, they're just big metal slabs. So yeah, that, believe it or not, does kind of qualify me to talk about this. My degree is in geophysics. Unlike a smart person who would go out and use that to work for an oil company, I used that degree to locate utilities for 13 years. This is a necessary thing because anytime you're going to go dig on a property, you kind of have to know what's underground so you don't break somebody's gas line. That wouldn't be good for anybody. So I did utility locating on a lot of fuel terminals, gas stations, industrial properties. Whenever they were going to excavate, test the soil, whatever, they would call us. And I use the 4 primary instruments that I used. This is also GPR, like we saw in the first photo there. This is the best one that we used. A few years ago, we actually came in and had everybody from all the commercially available reps in the country come in, and this is the one we decided was the best. This is the GSSI dual frequency from New Hampshire, I believe, is where they're located. So we'll talk more about GPR later. These things we won't really talk about, but I just want to show you, if you really want to nail down what's below you, you can't just pull out one method and hope that finds everything. You really have to throw a bunch of different things at it. This here is a metal detector that we used. I don't know why he's holding it like this. He really should be holding the strap to get it low to the ground. But this is good for finding underground storage tanks, which is a big issue with property transfers. Because if you buy a property that has a storage tank on it, you now own it. And if it leaks, you're responsible for the environmental cleanup, not the person who put it there. So if you're going to buy a property, get a geophysical survey done first, and don't ever buy a gas station. Let me tell you that. These two are line locators, basically the same thing. They just use different frequencies, and I'll explain a little bit more about why in a sec. This is a subsite. Mine were old and gray. Apparently the new model is green. You can see here, by the way, I stole all these pictures if you're interested. None of these are mine. So you see this little red lead here connecting to, this is the gas meter right here. I'm hoping he's hooking on a tracer wire or he's not going to find much. So you hook your hot lead to the pipe or the wire or whatever. And I don't see his ground here, but typically you have to put your black lead, the ground, somewhere else, typically 90 degrees away. And then that will complete the circuit and put a signal through the pipe or the wire. And then you use this, that's the transmitter here. And then you use this little receiver to pick it up and trace it out. You paint a line right above where it is on the ground so people know. And this is the same thing. This is a Dynatel from 3M. Yes, those tape people, same people. And this is the same thing. It just typically uses a higher frequency, which is better for finding narrow gauge wiring like phone lines and electric lines, whereas the subsite uses a lower frequency, which is better for finding things like water pipes. And again, I'll talk a tiny bit more about that in a second. It's important to understand where the Skinwalker Ranch is. And especially when we're saying, is GPR the best methodology for investigating the subsurface for whatever it is they think might be the underground causing all these strange things. So this is, I kind of tracked this down. This looks to be pretty much where the Skinwalker Ranch is. You can see this mountainous feature up here to the north. Salt Lake City Airport and Salt Lake City are over here somewhere, about, I forget how far away, but it doesn't matter. So you see this mountainous feature here, and the Skinwalker Ranch is kind of in a basin here. You can see Uinta Reservation. Again, that's the Native American tribe, the Indian tribe that a lot of the Skinwalker, excuse me, legends come from. The property changed hands a few times. It seems to be really just a ranch, like the name implies, for most of its existence. So there really shouldn't be too much going on underneath it, as far as I would guess. You know, just giving my general knowledge. Robert Bigelow bought it in 1996. He is, well, he came to fame through low budget hotel chains, but he eventually started an aerospace company. I don't know how that connects, but he's also a famous weirdo who is into really weird things. And so from 1996 to 2016, he owned this because of all the weird reports of it. And now someone else has bought it, and that's where he got really amped up, and he's the one who wanted to do this TV show. But anyway, so it does seem to be like a regular ranch for the most part. And so again, this mountainous feature, and what do we know about mountains? You can see these rivers, channels, whatever you want to call them, streams, coming down into the valley, bringing sediment down into this basin. So we can tell that, you know, that's physics. Physics really informs geology. You know, the way things flow and gravity, those are pretty universal things. So we can make those assumptions. And if we actually go ahead and look at the geology of Utah, don't cross your eyes looking at this too hard. I'll try to explain the important parts. Here's that mountainous feature. You come over here and you look at the rocks. That's Precambrian rock. Precambrian is very, very old, before the Cambrian explosion, before all the major forms of life as we know them developed. And that's not unusual. That's typical, because when a mountain range rises up, it's pushing any sedimentary rock that is on top of it up, eroding that faster. And most mountains you see are going to be all shield rocks, as they're called, basement rock. They're going to be the igneous and metamorphic rocks that were formed very, very early after the Earth really just first cooled. Up where I am, we're in New York, and you go up in Canada, you've got the Canadian Shield. Very, very shallow bedrock. And it's all, like I said, igneous metamorphic rocks that were made 4 billion years ago or something like that. So this mountainous feature gets eroded, things flow down into here, and then you see this light brown early tertiary. That's part of the geologic era we live in now. We live in the Cenozoic era. Quaternary is the most recent part of that. Tertiary, as you can probably guess by the word origins, a little before that. So you've got these tertiary sediments, these quaternary sediments in here. In other words, deposited very recently, coming down from this mountain. You can almost see, in fact, let's go back. hey, look at these features, these alluvial features where things are flowing down. Hey, look at this. Isn't that cool? So yeah, very, very recent sediments. Basically, all the sand is coming down into here. And that's really good. That's really good for GPR, believe it or not. Because, well, before you stare at that, sorry. Sand is the best thing for GPR signal penetration because dry sand specifically. Because what you're doing is you're injecting a radio frequency into the ground. You want that signal to be conducted as far into the ground as possible. If it hits, say, the water table, water with ions in it, with minerals, is very conductive. It's going to scatter the signal, and it's not going to get any further into the ground. And it's the same way with like clay. You'd see clay up here closer to the mountain itself because the smaller particles precipitate out of the alluvial streams sooner, because as soon as the energy kind of starts to diminish, those smaller particles, they drop out. Actually, I got that backwards. I'm sorry. The coarser particles drop out sooner. So down here, you'd expect to see more of the silt. But sand, either way, is being dropped down into this area. And, yes. So that's very good. The clay is very conductive in and of itself. So again, that's going to scatter a signal. But you got a nice clean sand, as you do out here in the Uinta Basin. You're going to get really good GPR penetration. That's a good thing if you're trying to find stuff. I'm going to try to do this very briefly, a little theory on GPR. So here's your cart like we saw before. That's the kind of like the cart that I pushed. And you start, let's say, for example, you start over here by the left, and you keep going this way. And like I said, I was locating utilities. So here you're seeing different feature. And here you're bouncing off this pipe, and you're getting all kinds of weird angles coming back. And the instrument can actually triangulate where things are. And that's what you get over here. Because as you get closer, you start getting some of those reflections, then boom, you're right above the pipe here. And then as you're walking away, you're getting some more reflections coming out over that way. And you get these hyperbolas. They're like inverted parabolas, if you're a math nerd. Yeah, and the reason you get these reflections is because of differences in what's called the dielectric constant. You don't really need to know what that means. Just think about when you put a pencil in a glass of water and it refracts and it looks different because the light is changed by the different properties of the water. The direction and the speed of the light is changed. Now, obviously, that's refraction. Some of that light is being reflected back at you. You can see the glass. You can see the pencil. So you got both refraction and reflection going on. And it's because of the change in properties between the air and the water. And it's the same kind of thing here. If you've got a different, like say this is sand and then you've got silt or clay underneath it, this boundary is going to cause a reflection, and you're going to be able to see that on your instrument. Same thing with if you've got a metal pipe in a bunch of sand. Obviously, those materials are very different, so you're going to see that. Now, if you really want to figure out what's going on underneath your feet, this is kind of what I did, because I was just looking for, let me go back. I was just looking for pipes, so I could just push my way over things, say, hey, there it is, go back the other way and say, hey, there it is again, and mark it and keep marking it and keep marking it, and mark it out that way. But if you really want to see 3D features and structures, like, okay, Skinwalker, they were worried about, I don't know, alien bases, military bases, tunnels, something weird under the ground. Then you really need to just set up a grid like this. And when I say set up a grid, I mean you got to do it fastidiously. This needs to be orthogonal as you can get it. You want those to be 90-degree angles. You want these spaces to be exactly the same space apart, whether it's 2 feet, 2.5 feet, whatever you want to do. And you really don't want to go more than 2.5 feet, because you need to get that antenna, the GPR instrument, directly over whatever you're looking for, kind of like what we were saying before. People used to ask me, well, there's a car parked where that underground tank is supposed to be. Can you tell from here if it's there? No, I need to be over the top of it. What do you think I do? We're good, but we don't do magic. Physics is not magic. So you really need to, keep these lines equidistant, keep the angles good, because then after you collect this data, well, first of all, in the field, it's going to look like this. These are actual radargrams, and these are actual hyperbolas from things. And now it's hard to say. I would probably say these are probably utilities of some kind. They could be boulders, because you would have to go back and forth. Like if you went over this spot and say, oh, look, there's something. I would then turn around the other way, go back, maybe 5 feet away, and see if I still saw it. If I still saw it 5 feet away, it's probably a utility, right? I'm trying to go 90 degrees over the utility to see if I can mark it out. If I go over this once, come up 5 feet away, and then go back and I don't see it, it's probably a rock or something, okay? Yes, so that's what you'd see in the field, and ideally this is what you'd produce back in the office. Again, you can kind of see, imagine these are grid lines, because they probably are, going back and forth, and it is important to go, let me just go back. Oops. It is important to go both ways. Well, actually, it is important to go both ways, once this way and once orthogonally, because if you have a pipe oriented this way, when you walk this way, you're not going to see it, because you'll either miss it completely or you'll be right on top of it. You really need to go orthogonally across it. So that's why it's very important to do a grid and not just one direction. And hopefully these are the things you would make once you post-process it. You could see kind of three-dimensional things with your hot and warm colors here. We didn't do a lot of 3D processing because, again, it was industrial, commercial applications. They just wanted to know where pipes were, so they didn't break them. So again, here's the star of the show. This is the big player in this particular episode of Skinwalker Ranch. This is the 6X160 GPR from Mala Geosciences. So a few years ago, we needed to buy new radar units. We decided on, like I said, those utility scans from GSSI. We had everybody who had commercially available radar come in to demo for us. And we pretty much unanimously decided that Malas were the worst. So I don't understand why they brought the Mala salesman in to do this. If they were serious, they probably just didn't know. I mean, when I say the worst, I don't mean terrible necessarily, because the physics is all the same. It's all a matter of presentation. And by the way, these sleds on the bottom are really shitty, and they would break and, kind of get holes in them really quickly, which isn't good, because as soon as the antenna underneath gets damaged, it's pretty much done. You have to buy a whole new one. And I don't know if you have 35 grand lying around, because I sure as hell don't. So this was, again, this was the 160, which meant literally 160 megahertz was the frequency. So here we go on this, and I swear I'm going to gloss over this as quickly as I can, because I don't want to put anyone to sleep. So the lower frequency, as you can see here, are longer wavelengths. Higher frequency are shorter wavelengths. It's an inverse relationship. And you want to use lower frequencies when you want to penetrate deeper into the ground and see bigger things. So it's probably a good idea to use what they use, the 160. I might go a little higher than they did. And the reason this is because if you imagine the wave actually moving the rocks, or the wave dissipating in energy as it goes through the rocks, obviously if it's waving more within the same period of time, it's kind of like resistance in a pipe, if you want to think about it that way. Resistance in an electrical line. It's encountering more resistance, but we call it attenuation. It's attenuating more over the same distance if it's a higher frequency, because it's waving more. So the high frequencies are better for shallow things, little things. You want the wavelengths to be about the same size as what you're looking for. We typically use 250s is what we did, 250 megahertz, and that works out to about a meter a wavelength. So, that's a little bigger than the pipes we were looking for, but in practice, that's what we found worked the best. We're not going to talk too much about this. This was a different unit that they used. This GPR expert, quote unquote, that I've looked him up, and he's a salesman. Salesmen usually know their shit, but sometimes they don't. I'm going to try to contact him. So you guys are kind of seeing a preview of what will hopefully be a Skeptical Inquirer article. But I can't write the article until I talk to him, because I got to give him a chance to defend himself, because there's a lot he needs to defend himself on. He called this this other unit a dual frequency. It isn't. I looked it up. It is the Mala Easy Locator wide range. This is the one I pulled directly off the Mala website. Obviously the same thing. Now that's a kind of a fine distinction, but it's an important one because I think the dual frequencies are a lot better. Those GSSIs that we had were dual frequency in that they had 300 megahertz and something like 800 megahertz. So you could look at them separately. You could say, all right, show me the shallow with the high frequency, show me the deep with the low frequency, or you could mix them together. And you're seeing a lot more than you would with one antenna. And this is, like I said, this is a wide range, which doesn't have those discrete frequencies. It puts out one signal that, again, this is according to their website, is from 80 to 950 megahertz. That's a huge range. I would say too big. You're not going to see those upper and lower ranges. You're not going to see anything useful in most places. And again, this is, you're kind of smearing everything out instead of looking for those discrete sweet spots at 300 and 800. Again, if you talk to people in the industry, you know, it's like I said, it's a fine distinction. But the dual frequencies are probably better than the wide range. And just the fact that he called this the wrong thing, even though they identified him as GPR expert, I think is worth noting. Okay, so they put that the 160 on the back of their vehicle, and they tow it up a path. All right. Now, first of all, this is weird to me because again, you don't really want to damage those sleds. But I looked at the Mala website, and apparently this is a typical thing. So I'll give them the benefit of that on this one. And this is the first radargram that they saw going along the path. And, you know, obviously History Channel was very nice, and they highlighted it here for you to see. We keep going along, and we get to the second one. Oh, hey, look, here's another anomaly. The GPR expert says, it looks like a dome. No, it doesn't. I mean, if you followed along with what we were talking about a second ago, you know, I explained the whole idea of hyperbolas, and he didn't use the word hyperbola. He didn't use the word parabola. He said, oh, it looks like a dome. Are you sure you know what you're doing? Okay, so there's number 2. I'm going to skip the third radargram that they show us, and you'll see why in a second. Here's the fourth one. Okay, this one was just towards the end of the line that they were collecting. And remember what I said. If you really want to figure out what's going on, you got to collect a grid. They collected one traverse up, one traverse back the same line, didn't mark anything, so they didn't know if any of the anomalies they found were lining up with each other. Keep that in mind. Okay, so here's the like I said, the fourth one toward the end of the line. Then here's the fifth one coming back. They say, oh my God, there it is again, right where we looked at it. Okay, well, I mean, I don't know how you know that because he didn't mark anything, first of all. But anyway, so yeah, I don't know if you noticed. Let's take a look at all 4 of these pictures together. And you guys think for a second. You don't have to answer audibly, but just look at these pictures and think to yourself if you see anything noticeable about these 4 pictures. Yes, Pam, you're right. They're the same picture. No wonder they promoted you to sales. You're very astute. Thank you very much, Ms. Beasley. Yes, this is not, I am not joking. They are not just similar. They are literally the same radargrams, even though they were presented as 4 entirely different ones. Let's go back. So again, you may not believe me. I'll give you my qualitative argument. As someone who stared at these things for 12.5 years, you kind of start to see the code in the matrix. You know what I'm saying? So you've got the same hyperbolas. But more importantly than that, look at this. You've got these same artifacts, these same 2 artifacts in the middle of each and every one. Now, this is very unusual because this is something that's almost unreproducible. If you go over the same object, like this is clearly a utility or a boulder. Again, maybe boulders just came down, you know, into the basin. And the problem with really clean sand is that, yes, you're going to see really well, but that means you're going to get a lot of false positives too. and you're gonna get a lot of things that you can't figure out what they are, because you can't take out your line locators and attach to something and trace it out. You don't know what you're seeing. You could be seeing utilities. You could be seeing buried structures. You could be seeing buried rocks. Literally, you just know something's there. But these little anomalies, these little data spikes, those are almost certainly caused by a rock popping up and hitting the instrument. Again, completely unreproducible. This is a dead giveaway. These are all the same image, and I'll prove it to you quantitatively. So if you take a look, this is the fourth and the fifth image, or excuse me, the first and the fourth image. These numbers, these are distance measurements. They're exactly the same. 1304, 1312, 1320, 1304, 1312, 1320. They're the same picture. All four of them, all presented as completely different things. Now here's number 2 and number 6. Number 6 was, I think, when they got to the place where they wanted to take out the other radar and push that around. Number 2 and number 6 are also the same picture, but of each other. 2 pictures presented 6 different times. Only 2 of them are unique. And let's take a look at these distance stamps. Yeah, as you can see, they're the same: 912, 920, 925, 912, 920, excuse me, 928. This one's a little blurry. And by the way, I don't think there's a way to reverse these distance scales. So these 2 images actually came before the first one. The one that they presented first was actually second. It's very strange. And I don't know how this happened. I don't know if the editors just didn't know what they were looking at. I don't know if History Channel was trying to get away with something. I don't know if these were just the best ones that they had through the whole thing, and they said, well, just show it again, because the other ones look like crap. I don't know. I'm going to try to find out. I'm going to try to dig a little deeper, but I think you'll agree this is beyond suspect. And here's what they showed at the very end of the program with their oh wow moments. They started, I took this clip, this snap, just as they started to put their highlights on things. So again, kind of like that data I showed you earlier. Again, this is definitely something. There's no question about it. Could be a boulder, could be an underground tank. This one, and you can't really tell width. You can tell kind of qualitatively, to use that word again, like this is bigger than this. You can, yeah, I mean, just you can see the reflection is bigger, the hyperbola is wider, but you can't really say, oh yeah, I look at that and it's clearly 8 feet in length. It doesn't work that way. Yeah, sadly. Some people think that GPR just takes a picture of the subsurface. Doesn't work that way. So yeah, these are definitely something. But again, as I hope I've explained to you, I mean, they're discrete things. Either this is a pipe that's going, let's say, in and out of the screen as we're looking at it, or it's a boulder, or some kind of structure, some kind of 3-dimensional structure. Each one of these represents that. One guy was trying to say that where these 2 tails, as we call them, meet, oh, it looks like there's an entrance to the tunnel. No. Again, if you remember that one diagram I showed you about how GPR reflections work, this is literally just the tail of the one object meeting the tail of the other object. It's not a thing that exists in physical reality. It is just an artifact of the data. And if you understood how to do this, you would know that. And here's a video that I want to play, and I hope it plays, of the big aha moment. And maybe if I've educated you well enough on how GPR works, you'll laugh as hard as I do.
We can't hear the clip. Is this supposed to be audio? Is there supposed to be audio?
When you say share this, when you say share a PowerPoint presentation, which has a video, you have to click another button to share the audio.
Oh, is that not working?
Yeah. No
We're not hearing it. Restart it.
Okay, you're not hearing it, or are you seeing it?
We're seeing it, we're not hearing it.
Okay,
Did you click the button which says share or share computer audio?
Thought I had. You're not hearing it at all?
Nope.
Not at all. We can see it, but we can't hear it, Russ.
Okay. Well, it's not
paused.
critical.
It's paused now, so we won't tell if we can hear it or not anyway.
Right. Well, I haven't changed anything, so It's not critical. Maybe I'll see if I can get it to work later. But the upshot is that the supposed astrophysicist, who is kind of the host of the show, let me, hold on. This was what he came up with. He literally took the peaks of all those hyperbolas and connected them. And then connected all those tails down on the bottom. And rather than saying, which is obvious to anyone who's done this for 2 weeks, instead of saying these are discrete objects or some kind of utility lines that we're detecting, he said this is a football-shaped object about 12 feet down, 1,000 feet in length. I tell you, I've never laughed as hard in my life, I'm pretty sure, as I laughed at this, because this is like, you know, the phrase they use about quantum mechanics about not even wrong. This is so bad as to not even be wrong, not even to be in the same universe that you and I exist in. But again, this is how this was presented to the national audience. And the radar expert was kind of silent through all this. Now, how would I do this if I really wanted to find a big 3D structure under the ground? In other words, the right way? Well, first, like I said, we'd have to do a grid. Otherwise, I mean, you could see those radargrams were all just traverses. They didn't do the 3D processing, so I don't know how good that's supposed to be. I don't think it's very good. And as you could see, they kind of dragged the thing behind them in a cart, which means look at all this forest and all this grass. You're not dragging that through here. So there's so much you're not going to cover by trying to do radar. Yes, it works well in sand, but you got to look at the actual field conditions. And they got all excited when the radar expert said, oh, it could be a metallic object. Yeah, it could be. It could be a rock. You want to know if there's metallic stuff under your ground? Use a metal detector. I mean, is that a crazy thing? And look at this is a Geonyx EM61. I've used this a bunch, unfortunately. So you got two antennas here, so you can actually tell depths pretty well by how much the signal decays between the two antennas. So that's pretty cool. The advanced GPS units are actually really good because you don't have to set up a grid. You can look at your handheld computer here, and the Juniper, I think it's called, and it will actually tell you if you're getting offline because the GPS is in real time. You have to set up a base station, all that, so it's kind of expensive and a pain in the ass. But yes, this is your metal detector that you can take on the grid, and this will detect down to say 10 feet, 12 feet, something like that. That's pretty good. That little handheld one that I showed earlier, that's only going to go down to maybe 8 feet tops, even for big objects. Even if there's like a train car buried under you at 10 feet, you're not going to see it with that little handheld guy. That's why you want this. Or even better, this is the EM31, also from Geonyx in Canada. I've carried this too. I've carried this in blizzards. I've carried this the day after the blizzard when it warmed up and I was knee deep in mud. It's not fun, so maybe that's why they didn't do it. But this also has, you can see this is longer. The length of the antenna also has to do with the frequency of the signal. Now this is big, and it's going to penetrate far, a lot farther than everything else. This will see down 15, 20 feet. And not only does it have a metal detector component, it has a conductivity component. So you can tell materials that are different conductivities that aren't necessarily metallic. So if you've got a buried foundation, that's the kind of thing you can look for with that. If you think they're buried concrete, use the EM31. Don't use your radar. So that's my diatribe on how they were clearly either trying to fool you or didn't know what they were doing, or both. And it kind of makes you think, like, not everyone is an expert on everything. So I'm an expert on this particular thing. And this episode was literally laughable to me. Imagine all the other episodes where they did gamma ray examinations, where they did this and that, all those other equipment, where you can kind of look at it and be like, well, you know, I guess I can understand that. That seems reasonable to me. Imagine if you put an actual expert down in front of it. Would they laugh as hard as I did? If you did that for an expert at every episode, would they laugh as hard as I did? Suddenly you've got the whole thing being absolutely ridiculous. And they depend on that because they know not everyone is an expert in everything. So this is kind of the kind of thing I do on AIPT Science. AIPT Comics is the website. We are mostly comics and things like that, but we do all forms of entertainment, movies, TV, everything, and these are a smattering of the kinds of articles, book reviews. These ceratopsians, the most accurate ceratopsian, triceratops type dinosaur figures in the world ever made, are coming out. They're finding their way to people right now. Even the coloring is accurate to the best of our knowledge. Here's something
Russ,
I wrote. Yes.
You're going a bit over time.
Okay,
so-
we're done. We're done. All I want to say is
the dinosaurs are nice, but we should move on. I guess
We're
we
good.
might have time. We might have time for one or two questions,
Okay.
perhaps. We can probably squeeze in. I'm just procrastinating before I have to go.
and of course,
Yeah,
all
let's
that
see
stuff.
what we've got here. Where's my participant screen? Okay, any questions? Anyone want to raise their hand for a question? Spiro has a question.
Yeah, I just want, it's not as much a question as just a comment, that one of my patients is a forensic engineer, and he's in charge of, looking at crash sites and figuring out what went wrong. And yet he believes in dowsing. And the two of us went dowsing one day in a parking lot, and he is convinced that this works, and it's just another.
It's confirmation bias. I've seen a lot of people douse in the field. They will go over a line that I already marked and say, "Oh, you're right, it's right there," but they never find it before I do.
Right.
All right.
Or they'll use clues. I mean, if you know where like the shutoff valve is and where the meter is, obviously it's going to be between those two things somewhere. So if you can get close enough, you can convince yourself that way.
All right.